welcome to the last presentation of the afternoon, I think, from Stuart of Oxford University.
Hi.
Moving department.
Yes. This is actually two talks in one, because I had another talk prepared to give tomorrow, but we've had to merge them two together. So, the news is you have to move a whole department, and everybody wants everything to work, so it all has to be done live, and it's going to take a long time, and they want to just do that move on as brief a period as possible. Now, if we've got all the servers over here, and we have to move them, why not look for somewhere convenient, somewhere nice to get them to, so you can start early, because everybody wants everything up and working all the time. The key thing is preparation time, doing as much as you can ahead of when you need it. It sounds obvious, it's really easy to say, but if, say, you had to move at the end of the year, you know, we're moving to a new home in December, would you start now? The answer is yes. You need to be working out how everything moves, so you can probably get, as we did, the servers moved, if you can find somewhere to put them. So, data centers. They're useful for all your key equipment. You've got the design teams, meet the architects, get everything sorted out in terms of what goes into the building so all the IT kit can follow with the users who want to work instantly there. And the final stage of pack it all up and move it. That's a big day. But as everybody wants to arrive, plug in and go, you need to plan everything ahead. And I'm going to try and cover everything we did to do it. So we'll start with the data center. First of all, you've got to find a data center. I was lucky, very lucky, because I looked around and we could consolidate we had three server rooms that were local to the users to save bandwidth having to cross the campus to get back to one place. Now, should I depend on the builders having something ready before the building's actually opened in our new home? Now that's great if you don't want to go outside and visit, 10 minutes down the road or somewhere like that. But you depend on all the project and everything coming together. Whereas right now, if I say all of you are the servers and all of you are the users with the desktops, laptops and all of that side, and I deal with that over the next 6 months, I can then have that working fine for when we're moving all of you. And then I've only got to focus on the desktops and user side of things, and hopefully everything in the server room ticks on quite happily and I don't even have to go there. I was lucky. There was a newly built data center. It had space. Okay, so you've got somewhere to put all your servers, but can you connect them to your new home? Can you connect them to your old home? And that's where dark fiber was key. So, what can we do? We go and have a chat with networks, ask what fibers are around. And very fortunate for me, they found that we had some spare fiber going to our old homes, and they tested it and it worked. And there was a project to add extra fiber around campus, and that would be in place before our new home opened. So we could get connectivity from the new data center to everywhere that we needed it. So, the obvious thing is racking. Now, if I pick on all of your servers, and I go, okay, you're sitting in racks I've got today, and I've got to go and put them, move all that kit across. If the server racks are the same depth, and that's the key part, it's much easier to move everything. And that was the first problem we had. The power strips were all vertical at the back of the rack. Now that's fine if you've got shallow servers. If you've got deep servers, they won't actually fit in. Or you might just get them in if they're kind of mid-depth, but you can't get the second power supply out of it. It has a failure. It's a hot swap, but you can't actually move it because of all the other all the cables and the strips. I've got a strange labeling system that I quite like. I use airport codes, terminal number, and then the device. It's short, it's easy to put on things, so label everything. That's my approach. So, in the data center, there should be 2 power feeds, and they should be delivering to the racks A and B power. What we got them to do was come up with a new power strip that went horizontal rather than vertical, And remember, this is all done in your early planning stage. If you left this to December, you wouldn't be able to order it, you wouldn't be able to get everything set up and going. But we're 8 months, 9 months ahead of the actual move. You've got time to solve problems that you would hit if you didn't plan things out. You've lost a bit of space due to, in the horizontal, the number of views or servers that you can put in has gone down. So at the top of the rack at the back, we have the two strips. They're actually, you've got the power, fuse, indicator that all's well, but these also latch onto the cables, so they don't accidentally drop out. You have to actually push that button there to take that cable out. Things don't kind of work loose when you're moving other things in and out, which sadly does happen, but then your services get disrupted. And that's it at the front. Individual fused circuit feeds to every box. So if there's a fault somewhere, say this server here is suddenly taking too much power, I don't lose that whole rack, I just lose that one device. Or at worst, I lose that row. But I don't want to lose the whole rack. Now, having moved us from vertical power to horizontal power, we can now put the verticals at the exact spot. We don't need to have drills, find that magic bit of thing that you threw away 2 years ago because you didn't think you'd ever move that server rail because the rail was that depth and I now need to make it that or that. We've all been there, and the kind of easy fit racks that are slidey are great, but you don't have it for everything. We also discovered we had some servers that were going to be deep. These are 1.2, these need a rack that's 1.2 meters deep, and at this point we only had 1 meter deep racks. We didn't expect it, but by the time you put GPUs in, your cooling fans, 2 CPUs, the rest of it, it's a deep thing. So we've got one rack that is extra deep. So that's for kind of GPU functions. Now, we've got all our racks in a nice row, and if I put, say, a switch there, I might not need to put a switch in the next rack. I might simply be able to save on the number of switches that go in, so 48 ports. I may not have 48 connections in that one rack. Commercially, I know they put switches and KVMs and everything in all the racks. I'm not that rich. But could I do a connectivity? If halfway down the rack I put a constant row of cable management bars, I can end up with a kind of management bus, a network bus, a 10 gig network bus, all neatly running at the same level all across the row. So we end up with cable management. You can then stick in your 1 gig switches, your 10 gig switches that will be feeding those, and your KVM management. So that gets everything. You've now got the services to support the servers that we haven't yet moved. But we've got the network there, well, the switches, we've still got to connect it all up, and that's what we're going to do next. Okay, on the old campus network, every building had a connection to the network, but you didn't have multiple connections. Everything was carried across a single 1 gig link. But you can run on that internal connection, so you've got lots of annex buildings scattered across the campus. So let's say my primary building there, 1, 2, 3, 4 other places, they all hang off the annex extension, which is just a VLAN, and you can do Q and Q within the campus VLAN to get departmental VLANs everywhere. That's great. They do have to make the packet size slightly bigger, so there's a few tweaks to be done. But that's how we connect everything up. Now what we want to do is use that dark fibre that we've found, buried in the ground, really convenient, and we're going to light it at 10 gig. That's going to get us out of having problems of bringing everything together into one place that was previously scattered around each of our buildings. So, a nice little quick picture of it, and what we're going to do, set up 10 gig Ethernet. If you ever have to go out and buy Ethernet adapters, the NICs to go into switches, you can go and buy from the switch vendor. They'll be very happy, but there's also third-party markets out there that can sell you tailored solutions for a fraction of the price. So, get it all installed. This fibre hasn't really been used for a decade, 2 decades, so I was a bit cautious. I set up just test networking and monitored any error rates. They were 0, but I didn't want to start moving production services until I was sure I had a stable platform. A piece of fibre might have needed to be cleaned, things like that. Then set up a test network. Does it do what you're expecting? Yes. So we're now getting to the point of configuring things for real. And here there's a great opportunity to set up a 10 gigabit link that goes into a loop. Your users will notice this. Central networks may well notice this. Your phone, if it hasn't moved to VoIP, may also ring, and some people will be chasing you. Luckily, it didn't happen. So we've now connected the red lines of the 10 gig links, so our buildings are now connected directly to the data center. We now create all the VLANs we need for the whole department across all these new switch ports. And once we're happy, we pick on a lucky VLAN, you sir, and we're going to move you onto the 10 gig network. Does it work? Oh yes, packets are going. Okay, we'll do the next one. And the next. And at what point do you move the most critical network? Well, you announce that first and say, this morning we're going to do, and very early, and it works. So you can now move everything across. You've tested it, you've tried it, you can monitor it, and just ramp it up like that. You now do that for each of your buildings are all moved across. Switch configuration and human errors. So you might have, if you type it all by hand, you might make a typo. But if you've got it generated by a script, I'm dropping it into the command line interface because sometimes with web interfaces, I've found errors in the web interface that results in problems in your config. So my preference is command line. I know it's old and probably not the fashionable way to do things, but there you are. So now everything's connected up. We've got the new location, and now we've got to do the server moves. Now you might think, well, why don't we just shut down all the servers in that building, and then all the servers in the next one, and just move them in one big bang move? No. You'll upset all these users over here. So why don't we agree that your servers are these two, and we're going to shut down just 1 or 2 at a time. No big bangs. Move them across very gently. Now, for moving things, you want a checklist. You want to make sure that you know where that white cable goes. It plugs in there. You might want to photograph it before you disconnect things. Because you don't want to pull it out and then go, did that go in there or down there? It's obvious, but how many of you disconnected the wrong thing or thought it was in the other place? Document it, note it down, because you're going to need to put it back. Now, as we're only going to do 2 or 3 servers at a time, hopefully you can remember it, but have the paper backup, have the photographs. You can throw them away at the end of the day once it's all happy. But it's a lot easier to get yourself out of a jam. The KVM dongles all look the same. So sticking a label on them to say that it's that one's for yours, that one's for the other one, that works well. You might think that all the racks, so the sliding rails are all the same from that manufacturer for that model. That may not be true. You might be lucky, but you may find it's worth documenting what each set of rails match to. They may helpfully already have left and right on them. Front and back, but not the model number. And small plastic bags to lose the screws into, label it up, put it in the box, and ship it across. Now, key thing here, we're moving servers. We're not updating the BIOS, changing your firmware, installing the next operating system release, repartitioning the disks, and doing 101 other things. We're simply moving the servers. Because otherwise, you suddenly discover something that was supposed to take a couple of hours, or it's now, or I've got them in the rack, it's 5 o'clock, and that firmware hasn't quite worked as I expected, and it's now 8 o'clock. and you may or may not get, and now your users aren't happy. Nice and easy, just keep it simple. You're moving servers today. Do have some kind of color scheme for your patch cables. This is something that we've been using, but you don't have to use these colors. Just have a pattern so you immediately know that this yellow cable is the KVM. And moving days, we don't do it on Mondays or Fridays. So it's Tuesday, Wednesday, Thursday. Check the weather forecast. If it's torrential lightning storms, no, it's not a good day to move. So skip it across because you're not under time pressure. You've got time because you're way ahead of the actual move at the end of the year. It's only March, April, May. I think we finished them in the June, July time. And do label everything. Dropping your servers is probably not covered by the warranty. So having a couple of people to help get that little thing out of that one high up, put the heavy ones lower down, the lighter ones higher up. Obvious, but if you plan it out ahead, it's much easier. You know where everything's going. You can get everything labeled up. So you end up with something like this. All nicely done. And at the back, you've got your power. Now, many of the servers may, by default, take their main power from the first power supply. You can configure it in some of them, but I oscillate the pattern of connections. So say that's A supply, then A's over there and back there. You can immediately see from there we've got two power sources because we've got black and white supply cables. So if you make a mistake and end up with two blacks or two whites, you know that something's gone wrong. Okay, so that was the easy thing. I've got all the servers across there. And we're now going to come to the tricky bit, our connectivity to the campus and beyond. We have a firewall comprising of two Fortinet. They're called firewalls, but they're also doing IP routing, they're doing DNS, they're doing DHCP, they're doing NAT, they're doing lots of things. They're high available because that one can fall over to there in a fraction of a second. But they're in the old data center, and we have to get them out. So we had an idea. Why don't we kind of just move it and put the heartbeats going through the switch network? So first of all, you try it in the local data center at a quiet time when networks are at risk, and if it all goes wrong, you can quickly backtrack. It did actually work. So then we did the same, in theory, across the campus. And then you have to implement it. So you find out which one's acting as the secondary, and you turn it off. And you hope. And everything carries on working. I can still ping MIT, which is my favorite test of nice and easy, does work. And you check all your connections and configurations for the final time. Everything looks good, everything's labeled, and you disconnect it, you take it across, plug it in, and take a deep breath and power up. Now, two things can happen at this point. It all works nicely, or it all goes it all goes badly wrong. That's easier. So you've now got it to there. You now have to drop the other connections so they actually fail over. And at the end of the day, it took us, we were only down for some 20 odd seconds. In that terms of my pings to MIT and people's incoming connections were very short. So when you can find a solution that lets you do something drastic, like move your core of the network, that's great. If we'd only purchased one of them, we couldn't do that. We'd have to shut down and move the whole thing. So we're back to how it was configured before. We also wanted to phase out a number of old services. So we used to do, we want to have an easy way of devices that plug into the network get put on the correct VLAN. Various switch manufacturers offer it in different ways. I'm going to give this example. We're using Extreme switches, and when a device connects, sends out a packet, say it's DHCP request, it gets the MAC address, sends it to a free radius server that says, that MAC address goes on VLAN desktop. Returns that to the switch, it drops it in there, and it carries on on the correct VLAN. And it even works with phones. So the phone is on the VoIP network, but the socket on the side with your laptop goes on the right network. I didn't need this until January. But if I get it tested out in one of our buildings, I know it's working. Because I couldn't actually get the VoIP phones and that all set up yet, but I know I'm going to need it. So we're trying to solve the things that you know are coming, and if you can get it done now, so much the better. Our old NAT service, we managed to migrate it off a very old server that was due to be retired. It didn't get moved. Most servers got moved, but that one just got retired. So find something else that can do it for you if you've already got the technology available. We also spent, and this was a year or two ahead of even knowing that we were moving, looking at new Wi-Fi solutions. But by knowing what we wanted, we were able to specify it for the new home. So it was something when you move in there, you've got something that you're expecting, you're familiar with, rather than, oh, you've got Fred's new networking Wi-Fi service. You've got something you know. And that's key, because there's going to be so much to do when you move into your new home. So we've sorted out the data center, the servers, and getting a few things set up. We now need to meet the lovely team that are going to be designing your new building. The architects, the builders, the mechanical and engineering contractors, the carpenters, the AV specialists. The list is endless. And they're all specialists in their area. But they might not really know what you want in your IT area. So you have to give them a specification that is detailed, very detailed, exactly what you want for when you move in. Otherwise, you're going to be disappointed. And it's not really their fault, but they will have a consultant for you to talk to and discuss most of it with, and the project manager and the rest of it. You've got to make the commitment and do that drive. So, a summary of what we were looking for was one room you could walk into. We're not doing network boxes up on the wall that you need a tower to get up to. We're doing a room you can walk into and can actually do the patching, all the networking, the power, the security, the air conditioning, and make it all resilient. You have to ask for these things. You have to say how big all these racks are going to be. So you've got to work out how much estate you need. Otherwise, you might get a room that's tiny or something too large, but you probably won't hold on to it because somebody else will want that space. You also don't really want hot water pipes, steam pipes, mechanical services running beside all your lovely new network wiring. Because if something goes wrong, and probably with the plumbing, you then have rather wet and probably damaged networking. And there's not much you can do to recover it afterwards. So we went for a Cat6a screen solution. It gives you a less of a cross-section. The unscreened is actually a bigger cable. This varies over the years, but right now the screening was the thinner. You want it with manufacturer's warranties, not just Fred who installed it, but all the way back to the manufacturer to underwrite things. Because if there's a problem and it takes several years to be found, you don't want to be the ones that have to replace it. And make sure that you have a say on who they go with and how they choose. Now, you might think there's a lovely big IT budget in the whole building project plan. You might be very fortunate, but it might be smaller than what you really need. So you have to make sure they understand the importance. Like, do you need one air conditioning unit sitting on the wall, or do you actually need an N+1? Do you need 4 kilowatts of cooling, or 2 times 7, or 2 times 9? Depends on what they can fit in. But you have to argue for it. The other thing is, you might have a room. How many people are going in the room, and do they need 1 data outlet, or 4 data outlets, or how much power? Because often you find they'll trim these things back, but it's much better to get it done when the building is basically a building site and they're moving all that cabling in. Get it done, otherwise you face the disruption and probably the expense will hit your budget. it's very worthwhile going to all those project meetings. You might not want to listen to radiator and plumbing and the type of doors and the table and the furniture and the windows, but you're there to make sure the IT side goes well. That's your corner.
I had encountered in a previous role.
Yeah. It takes time, but it's well worth doing. So the installation went to a company that I knew from past experience, and I was quite happy on that. They basically took from September through to Christmas to get it all wired up, everything fully tested with a calibrated, decent testing unit. And fully labeled, we've got everything. So we've gone through spring, summer, into autumn. It's now December, and December's the time you're expecting to move in. Well, there's a small delay. Instead of being early December for you getting into the building, you actually get in on Tuesday the 22nd. It's Merry Christmas time. It then strikes you how much you've got to do. Because they patched it all, but you've got to add your power distribution, your switches, configuration, patch it all, and you kind of work, this is an awful lot of work. So right now we've got one working phone. It's in the network room, so that's the best place for it, you see. And we call campus network guys and say, can you get our ANX connection from our other buildings across to this port on the switch? They do that for us, and we can now see our internal networks. So we can now bring up a wireless access point, and we can get our laptop and phones and everything like that working. So we can now start to build things, and we can configure it up for testing. We haven't got the 10 gigabit links yet, but that will come when the fiber's available early in the new year, and we just switch that across. But we've got enough to get us going. So always have a backup plan. You might have expected one thing to arrive then, and it didn't. We then get a delivery of hundreds of patch cables, so boxes and boxes of them. So we're ready to patch in the new year. You go home and have a nice Christmas. Now, it's either watch The Great Escape for the nth time, or have a think about exactly who's going where in every single office, and make sure you've worked out that you're needing 3 ports and they need to be patched, and you're moving in on the Monday, but you're moving in on Thursday, so we can order who's going in where and get the rooms ready. So my whole team very kindly came in on Sunday the 3rd. The builders were still around. They had worked through pretty well the whole of Christmas, apart from I think Christmas Day and probably New Year's Day, and the place was fairly empty. So Wi-Fi goes further through empty buildings. It doesn't get blocked off and absorbed. So we were able to put in enough access points so that we could work. And what we wanted to do was basically get everything ready for the next day, and maybe the day after. Google spreadsheets can be used by multiple users. So you can be sitting in an office on the 3rd floor, and you can be sitting downstairs in the network room. He updates the spreadsheet to say, patch this port for a printer, and you can then do the patching. He sees that you've done it, and you don't have to run up and down the building, which may or may not have a lift working at this point, and get everything done. So we actually do a 2-pass process. We go around patching everything in all the offices. The guys downstairs do the actual patch, upstairs then do a 2nd pass and test it. So we've tested the ports ready for use. The users then turn up during the week and find things are ready for them, rather than having to go, oh, it's not working. Can't send an email. So during the somewhat rapid build, it's looking a bit like that, but we do get the doors on. A bit tidier that way around, and the key thing is to try and get your cables from the left and the right nicely separated. That's feeding all the patches down that way and down that side. Obvious, but it takes a little bit of time to do. This is the dry riser running up the whole building. No users get in there, but it's spread out, it's got room for expansion, and you've got enough airflow that the cable bundles don't overheat if there's maximum power over Ethernet demand. So at the end, this is how we've kind of got it connected up. It's early in the new year, and we've completed parts 1 and 2. You've now got the fun thing of moving all these users in. Fortunately, there's a company that's going to do the actual moves, building by building. We go in there first thing in the morning and disconnect everything. But we need to know where everything goes, and that's important, because the contractor needs to have everything labeled. So we tell the users to stick labels on everything that's got to go across. But we've also got our own offices to do. You've forgotten about them, haven't you? You're always looking at everything else they need doing, and you were going to have a really good clear out, weren't you? All those manuals from decades ago were going to go, yeah, okay. So, on the morning of each move, we basically disconnect everything, move anything critical ourselves. Canon came to move the big photocopier multifunction units, and it's basically going to take several visits over the next few days to sort everything out. But the key thing we're after is switches that will be needed later in the week to get them across, configured and patched in for you arriving, say, on the Thursday. Perfect. You may arrange a Wii collection for the things that are just no longer wanted and get it safely sorted out. And keep your wonderful Google spreadsheet up to date with everything that's happening. I'm going to have to speed up. So the analog to digital move, you've got to tell the users that their old phone isn't going to work well. It has to be a new phone. Some of them were just, oh, my lovely phone. It won't work. You can get converters, but we didn't want to go down that way. So we arranged and tested out the list and agreed everything. University Telecoms did the main move for us. The Wi-Fi was put in by the network installing company to the design of the Wi-Fi supplier, and that all worked great. So we just get rid of the old connections and the old buildings, and then during the summer we add in the new campus network, and that migration went very well. A few pictures, what it looked like, and I tried to get cake introduced into this talk, but nothing happened. So there is my cake, and that's where we are. Now, very quickly, we had a very old Sun SPARC server. Very reliable, it worked really well, but it was getting a bit overloaded at times. And you kind of look around and ask, how many files have you got open? Now, Linux can tell you for each NFS server just what the users are doing. It's hard to get that out of the Solaris server unless you run some magic low-level code. So say you've got a couple of hundred, you've got 700. Gentleman there's got 5,450. A few of those scattered around, we suddenly discover why this gets overloaded. So it needs to be replaced. There's lots of options out there. There are still Fujitsu SPARC servers available. You can get a nice one-use SPARC box. There's various ZFS packaged appliances. They don't seem to be too positive if I ask about, can I run this script to do things inside it? But we were running out of time and we really needed to do things. Now we buy lots of Dell boxes, so we went for 3 servers dominated by disks, spindles, and heads to get the speed. And these present up through LVM as mirrored pairs. Now, I do like ZFS, but we were slightly early in as far as it wasn't yet backported as far as I could find. But we do have the backported version on our backup server. We've got plenty of bandwidth, 6 10 gig interfaces. That looks nice. We can spread it across the switches. We can basically use MLAG to give us a self. You can even upgrade one switch whilst the other one's taking the traffic. Unfortunately, it panicked. So we simplified it down to one connection, perfectly good, and it still panicked. And we actually found that backporting the kernel solved the problem with newer firmware. It was just too new on the hardware front. At the present time, we're using ext4. It's working fine. We give every user their own file system, and that's worked out very well. You can grow and shrink the file system as you need. We have to decide a simple method of where to go. So if you're a member of staff, you go on the first file server. Otherwise, we take your Unix user ID and module by the number of those file servers. So in this example, it's modulo 2 to work out where you are. But it will work for any number, and it's a very easy sum to do. We also give them more friendly names than file server 3. Backups are the most important thing, because users do go wrong, make mistakes, heads crash, disks go wrong, and sysadmins apparently can sometimes make a mistake. Wouldn't know. So we're using the Debian ZFS backport on our online backup server, which we recently expanded using the Dell JBods. Previously it had come from the ext4 area, where you've basically got the RAID unit in the hardware. Deduplication is very tempting. However, there's been various warnings more recently about staying away from it, and I have had problems of the server taking some considerable time to boot up after an unexpected crash. So we're moving away from that, but we are using LZ4 compression. If you say suddenly need your file and I've got to go hunting for it, I need to find it on the storage. So I've gone for something simple. Data 2, which is the volume, users, first letter, and then the person. That way I can easily find out where it is, and I've got ZFS backups, snapshots hidden inside there. So I can restore your data very easily, fingers crossed, very quickly. We're doing snapshots every 15 minutes, kept for the hour, hourly for the day, daily for the week. You can see the pattern building up here. And a simple naming scheme. Keep it simple, keep it clear, because when you're under pressure to get things back, you're in a rush. Do establish a really good, clear workflow for moving everybody, and pick your first users very carefully. I went for one by one rather than a big bang of, we're shutting everything down, nothing will be working, because if it doesn't come back very quickly, you've got problems. But if we pick 1, 2, 3 users and just move them in a slot, we're okay. I moved the head of department as the first user, and that was interesting. They were very good. So choose your users carefully. Basically, we had 1 week of unexpected panics until we went for the backport, and then it's been rock solid stable since then. And the news then traveled. This is so much faster. This is so much better. And we got tons of people wanting to move. You do get a tail end of people that are really busy. Accommodate them, because the end servers, the old and the new ones, can all work happily together. You've not got a really fast turnover. So that's about it. And I found this picture on the web. That's all your data going across the network between the server and the department. Any easy questions? Yeah?
When you were patching the new building, and you were saying you patched up the sockets into an office and then left the message to take them downstairs, were you actually tracking that this one on the left is exactly coming out on the patch that we expect downstairs, or were you just happy that there were 4 things that were all connected to a switch?
We were basically going by, we would describe your office. You have a PC, a laptop, and a printer. And they've been assigned names to those 3 ports. We then patch at the other end into the switch and just say it's now done. If you flipped around printer and PC, we may not pick that up. We might do if there's a problem, and then we'll know. But users sometimes move things around anyway. Yeah?
With storage of MAC addresses and the radius server, is that something you're just putting directly in there? Do you have some back end that's
It's a simple script table that just generates the actual free radius syntax. So I've got a table that's got MAC address, the VLAN we want, and I think a comment field. And then that's turned into the actual syntax that you feed into free radius. So it's generated for you.
I think we are got 1 minute left for any last questions. Thank you very much.
Okay, great, thanks.